Okay, hello, and in this video I'm going to talk about the first part of topic 1 is about the functions. So the first thing we are going to do is go over the definition of functions. So the function is a rule for the relationship. So we are talking about the relationship between some quantities here. And the first quantity is called the input. And you can also call it independent quantity. And the second quantity is called output, or you can say dependent quantity. So the relationship between those special quantity is a function. And at the same time, we say each input uniquely determine one output value. And I'm going to highlight the important word here. They say uniquely. So each input, we should only have one unique output. And then if the relationship satisfies the condition here, we say the output is a function of input. And then let's just draw a simple picture and show what does the function mean. So we have two quantities. The first one is called the input. Second quantity is called the output. You can also call input an independent quantity. You can say the output is the dependent quantity. Okay, and the relationship. So each input uniquely determines the output. The relationship is unique. And then we say the output is a function of input. So that's kind of the picture. And then based on the definition, let's just go over some simple examples. And I made some really silly examples here, so we can use the definition to check which quantity is the input, which quantity is output, and how to write down the notations here. So the example 1, there is a coffee shop, and I put the menu of the menu has the item and the price. Okay, so you can take a look at the table here. So the first thing I will do is check from the item to the price. And if it's unique, then we can define item is the input and the price is the output. So I'm going to check if the relationship is unique. So basically what we do is look at each input. First, the input black coffee. If you want to get a coffee, we must pay $2. We have a unique price for the black coffee. And second of all, if you want hot chocolate, you must pay $2. We have a unique price for the item. And the last one, if you want to get a mocha, I need to pay a little bit more, $3. We have a unique price for a cup of mocha. So for each item, we have a unique price. You must pay $2 for black coffee, you must pay $2 for hot chocolate, or $3 for mocha. So each item has a unique price. Okay, and because the relationship is unique, and we can use the definitions here. So the item is going to be the input, and the price should be the output. Then we have a function here. So the item and the price, the relationship is a function. Okay, and then I will double check the backward direction. How about if we go from price back to the item? Is that a function or not a function? Or is the relationship unique or not unique? Okay, so I look at the price. I can see two different numbers. So the price can be either $2 or $3. And if you have $2, when you go to the coffee shop, you can buy a cup of black coffee, or you can buy hot chocolate. So for this price, I have two items. It means the relationship is now unique. For this special price, I have two different items to pick. So it's now unique. Because it's now unique, that's not a function. Okay, if it's now a function, we are now going to consider the input and output. So the only unique relationship is from the item to price. And based on here, and then we can kind of complete the blank here. So the part A, what uniquely determine which quantity? So you can go back to the definition, and we say the input uniquely determine the output. So the first blank should be the input, second blank should be the output. And here the input is the item, and the output is the price. So the item uniquely determines the price. And the part B, which one is the input? Okay, input is the item. Part C, which one is the output? Output is the price. Okay, so let me erase that. Output is the price. And the last one, what is a function of another quantity? And you can take a look at the last sentence in the definition. The output is a function of input. So output is a function of input, and I'm going to put those two quantities in the blank. The output is the price, and the input is the item. So the price is a function of item. Okay, so that's the example 1. We can try a similar one, example 2. We have some numerical grade like a 100 point, 50 point, or 0 point. And we have percentage grade. I made some examples here. If you get 100 points, I'm going to convert it into percentage 100%. If you got 50 points, it's going to be 50%. And if you got 0, then it's going to be 0%. So again, I will check this direction first. If you got 100 points, you got 100%, that's unique. And if you got 50 points, I must give you 50%, that's also unique. If you got 0 point, I must give you 0%, that's also unique. So for each numerical grade, you only have one percentage grade. So the relationship is unique. Then the numerical grade is the input, and the percentage is the output. And because the relationship is unique, we have a function from numerical grade to the percentage grade. And similar as the example 1, I will also check the opposite direction. How about we go from percentage back to the numerical? Okay, so the percentage grade, if you got 100%, you must got 100 points. If you got 50%, it means you got 50 points. If you got 0%, it means you got 0 point. So for each percentage, you have a unique numerical grade. So the opposite direction is also unique. So the opposite direction is also a function. And then we can highlight which one is the input. So now the percentage is the input, and the numerical grade is the output. So from each percent, we can get one unique output numerical grade. Okay, so that's why the example 2, I have 2 parts, and I will use red color to do the first part. So again, the first blank, input uniquely determine the output. And the left side table, the input is the numerical grade, and the output is the percentage grade. So let me write down this way, percentage grade. And the input is the numerical grade. Output is the percentage grade. And the output is a function of input. So the output percentage grade is a function of numerical grade. Okay, so that's based on the first table, from numerical to percentage, that's unique. And because the opposite direction is also unique, I can also use the second table complete the blank. In the second table, the input is the percentage grade, and the output is the numerical grade. And again, the input is the percentage grade, and the output is the numerical grade. And the last blank, the output is a function of input. And in the second table, the green one, the output is the numerical grade, and the input is the percentage grade. So the second example is a little bit special. Okay, so both directions are a function. And then later we can go over this type of special function. Okay, so that's the example how to check given a table or given a scenario, how to check which one is input and which one is the output. Okay, and then last one, let's try the examples 3. Again, we have two things here, population and the garbage. So I'm going to look at the population to garbage. Okay. So population, I can see two different numbers, 100 people or 300 people. Okay. If we have 100 people, we can make 200 garbage or 400 garbage. Okay. So the direction is now unique. Okay. For the 100 population, you can have two different outcome and output. The relationship is now unique, so that's not a function. Okay. And then I will check the opposite direction from the garbage back to the population or the city here. And the garbage, we also only have two different values, 200 and 400. Okay. So 200 go back to 100, that's unique. But if you have 400 garbage, okay, you can have 100 people or 300 people. So again, that's now unique. Okay. For just 400 garbage, you have two possible populations. Okay. So that's now unique. That's also not a function. Okay. So both directions I can see is not a function. So the example 3 is another special case. Okay. Those two quantities are not a function. Okay. They do not have a form of not a function. Okay. They do not form a function, okay, based on the table. Okay, so that's all the possible 3 cases. And the first case, we only have one direction is a function. Second case, both directions are functions. And the last case, both directions are not functions. And they are all the possible cases. Okay. And this one, I also copy the same formula. So sometimes we do not have a table. Sometimes they only give us a sentence. You can figure out which one is the input, which one is the output. So example 4, they say population is a function of year. So you can take a look at the term I highlighted over here. Output is a function of input. Okay? So it means the population must be an output and the year must be the input, okay? Because output is a function of input. Okay? And then we can complete the blank. Year is the input and the population is the output. Okay. So later when we are dealing with other chapters, you can use this technique to see which one is the input, which one is the output. Okay. You can try the example 5. We say height is a function of age, so height must be output and age must be input. Okay, so input is the age and the output is the height. Okay, and then that's everything about the function. And some functions are special functions. They are called a one-to-one function. Okay? So one-to-one function has two parts. First thing, it must be a function. We talked about the definition of function before, so let me go back to the first definition we did. Okay? So definition from the input to output. Okay? The relationship should be unique. So let me copy over here. Okay? And at the same time, it should be a one-to-one function. So we have the second part. So the one-to-one function says every output also only have one exact input. Okay? So each output, we only have one unique input. Okay? If both directions are unique, then we say it's a one-to-one function. Okay? So the first direction say is a function, okay? And both direction means they are one-to-one. So all combined together is a one-to-one function. Okay, and then we can go back to the example 1 and 2. If you remember, we did on page 1. Okay? And you can go back to the page 1 again. So the first direction is unique, okay? But when we go backward, it's now unique. Okay? So what we can say is this function is only, this relationship is only a function, okay? But it's not one-to-one. Okay, because the opposite direction is now unique. And the example 2 we did on page 1, both directions are unique. Okay, for each grade, percentage grade, we can get one unique numerical grade. For each numerical grade, we can get a unique percentage grid. Because the both directions are unique, we call this function a special function. That's called a one-to-one function. It's a function at the same time is one-to-one. Okay, so that's about the definition of the function.